Hello, so this is going to be a quick overview of some working computer RAM that I built in Minecraft. So over here I have set up a very simple, using just plain logic gates. This is 1 bit of RAM here. So we have two inputs. We have write enable input and then our actual data input. So this redstone lamp over here indicates whether or not the data stored in this bit of RAM is a 1 or a 0. And so, as long as write enable is turned off, no matter what we do, to the data input, nothing on the output will change. That is the case unless write enable is turned on. That way, we can start to write data to the bit of RAM, and what we do will be saved. However, if, say, we were at 1, and then we turn it off, well, now we get a 0. So we can have a 1, disable write enable, and then change that to whatever we want, and it will store the value. So this is the same way that computer RAM works in a real computer, using just these simple logic gates. However, this is a little bit overcomplicated, and in Minecraft we have something a lot simpler that does the same thing. So this is another 1 bit of RAM that we have, which is quite a bit simpler and can do exactly the same thing. So no matter what the data input is, the output won't change unless write enable is present. There we go. Now, see, so this just uses simple locking repeaters. So the best way to scale up your RAM is with a matrix, and so that's exactly what I've done over here. So this is a matrix that contains 2048 bits of RAM, or 256 bytes of memory. So to use it, we simply have to come over here, specify a memory address, such as currently we have a memory address in binary as 0. Then we can write enable over here. Just a little bit of lag. And then we can put in our data. So I'm going to put in the number 255 in binary. Just like that. Then, if we disable write enable, we are still referencing memory address 0, so we come over to the output, we will see that we in fact have all zeros. Or sorry, we have the number 255 in binary. So if we come back over here and specify a different memory address, so say the memory address 1, and go back to the output, we have all zeros stored in that. So we can write a new value to it. So I'm just going to write the value 1. And as you'll recall, we do that by putting in the data over here. But it won't have changed unless write enable is on. So now that goes in and writes the 1 to the memory address 1. And so if we go take a look at the output, we should see a 1. And we do. So we are again going to go back over, and if you recall, memory address 0 contained the binary number 255. So if we go back to that memory address, we should, again, get the 255 that we had earlier. And as you can see, that works flawlessly. So now you can specify, you can do that with up to any memory address that you can fit in this 8-bit binary number. So the way that the memory addressing system works is for the first 4 bits go to the X multiplexer, and the second 4 bits go to the Y multiplexer. Now, these are quite simple. These just take in a certain input, and if that one input is true, then the output will be true. So in this case, if this takes in all zeros, the output will be 1. If this takes in 0, 0, 0, 1, the output will be 1. So, as I can show you right now. So this one is disabled, and this one is enabled. So that happens in the same thing over here on the Y multiplexer. So the multiplexer lines are mirrored to each layer, and we have 8 layers, meaning that 1 layer stores each bit. Same with the write enable line is enabled for all of the bits, or all of the layers. The data, the first bit goes to the first layer, second bit goes to the second layer, third goes to third layer, and so on and so forth. So that is pretty much it. Thanks for watching.